Welcome to Pre-Calculus Section 3, Functions and their Graphs. First we're going to talk about domain and range of functions. What is the domain of a function? Those are the usable x values. What is the range of a function? That is the resulting y values. Now let's look at some functions and find their domains and ranges. Here's your first function. F of x equals 3x squared. Find the domain and range. Pause and then check your answer. As you can see on the interval notation, the domain is negative infinity to positive infinity, and the range, because of the squared exponent, is 0 inclusive to infinity. Alright, let's check the next function. Find the domain and range by pausing and then checking your answer with my answer. Pause. Okay, because of the square root function there, the inside of that square root needs to be positive, so anywhere negative infinity to 0 inclusive. And your range is going to be anywhere from 0 to infinity. Alright, let's go ahead and check that last function. Go ahead and find the domain and the range for this function. Pause now, write your answer down, and then hit play to check it again. Okay, obviously the domain is for all real numbers. That's why I wrote negative infinity to positive infinity, because it says for x less than 2 or for x greater than or equal to 2. That would be all x's. The range, for the first part of that piecewise function, the result is always going to be some positive number, because x has to be less than 2. And then for the second part of the function, it can equal 2 or more. So that is going to be the square root of 0 or larger. That's why I wrote the range 0 inclusive to infinity. And that's finding out domain and ranges of functions. Let's go ahead and move on to the next page. Evaluating functions. Alright, f of x equals x squared plus 2. What is f of 2a? Go ahead and work on it and pause, then come back and check. Did you pause? Please pause. Try your work, then come back. F of 2a equals 4a squared plus 2. Alright, let's go ahead and move on to the next evaluation. F of a minus 2. Substitute that a minus 2 in for the x squared at the top. Alright, go ahead and pause this while you work on it and then come back. Pause. And your resulting evaluation is a squared minus 4a plus 6. I hope you got that one. Alright, the next one is a little bit crazy, but you'll see this with derivatives and the definition of a derivative all the time, so it's good to get you going on it now. Go ahead and pause right now. Now, muddle through it and then pause. Alright, see you in a minute. Alright, there you go. 2x plus h. It's kind of nice with these functions here that anything that does not have an h in it will end up canceling out. It just always works that way really nice, so that when you go to evaluate, you can factor out an h from the numerator and cancel with the h in the denominator, 2x plus h. Alright, let's go ahead and move on to the next page. Alright. Translations. Parent function is f of x equals x squared. How is the parent function translated if the new function is f of x equals x squared plus 7? If you want to put it on your calculator and look, you can go ahead, but if you do that, pause so that you can see the result, because right now I'm going to show you the answer. That parabola moved 7 up from the origin where the vertex originally was. What's going to happen to that parabola if we rewrite it as x squared minus 4? That's right, you guessed it. It will be 4 down from where the parent function originally was. How about f of x equals the quantity x plus 3 squared? How will that be translated? Yes, it will be moved 3 to the left. How about f of x equals the quantity x minus 5 quantity squared? How will that be translated? That's right, 5 to the right. And then how about this last one? I'll give you a second to think about that one. And there you go. It would be moved 6 up and 5 to the right. That's how you can translate functions, by adding constants either inside or outside the parentheses to the parent function. Alright, moving along. Degree functions. I did talk about this a little bit in class, but I thought you'd want to get it down in your notes. 0 degree function, first degree function, second degree function, and a third degree function. Of course, there are higher degree functions as well. Okay, what makes them what degree they are? Find the highest exponent for x. Okay. And what are the general tendency of degree functions? Well, I think you can read. Go ahead and pause this while you write these down in your notes. Alright, glad you got those down. Now go ahead and move on to the next page. Even function, odd function, or neither. Even function is where f of x equals f of negative x. Hey, we've already looked at the That's when a function is symmetric about the y-axis. And odd functions, f of x equals negative f of x. We've seen that already as well. Odd functions are symmetric about the origin. I'm not going to show you any examples of that because we've already done some problems with those. So let's go ahead and move on to the next page. Yes, composite functions. That's where one function is inside of another. F of x is 3x squared plus 5x plus 2. G of x is sine of x. The first one I'd like you to do is find f of g of x. So we're going to put the g of x into each one of the x's. Another way of writing f of g of x is f dot g of x. And it's read f of g of x. Same way. Alright, I will let you go ahead and work on that. Pause. And there it is, f of g of x. Now let's go ahead and find g of f of x, or g dot f of x. Go ahead, pause, and work. There you go. It is sine of the expression 3x squared plus 5x plus 2. This will conclude Pre-Calculus Section 3, Functions and their Graphs. Goodbye.